All right, so chapter 7 is on light. This is the last chapter of physics. So the next section of the book is going to cover chemistry. All right, so this is the last physics chapter of the book. All right, so there are sources of light. So we have the sun, other stars. We have our, you know, regular lighting materials that we have as humans. So our light bulbs, our materials that we burn to give off heat as well as light. So when something produces light, it is said to be luminous. And when we have visible light and it's given off as a result of high temperatures, that source is said to be incandescent. All right. So luminous is something that produces light, and incandescent is a light source that results as is a result of higher temperatures. So your visible light is emitted from incandescent sources. So sunlight is incandescent because the temperature of the sun is very, very hot. All right, so the radiation is called black body radiation because it perfectly absorbs and emits electromagnetic radiation. So this is how light interacts with matter. So you have a ray of light that travels and it's usually in a straight line from the source that it's coming from, and it travels until it encounters some sort of object or particles of matter. So what happens next depends on several factors. So it depends on the smoothness of the surface that it hits. It depends on the nature of the material that it's shining on. And it depends on the angle at which the light ray is striking the surface of that object or particle. So your electromagnetic spectrum is made up of a wide range of frequencies. So pretty much the higher the frequency, the shorter the wavelength. All right. The longer the wavelength, the lower the frequency. All right. So the shorter wavelengths are more dangerous than the longer wavelengths. So your gamma rays, your X rays, your ultraviolet rays, these are all high frequency, is on the high frequency end of the electromagnetic spectrum. All right. So this is why when you go to the doctor and you get X rays, they pretty much put a material like a vest over your chest to protect your heart and your other important organs because those waves from the X-rays are very dangerous. All right, so ultraviolet waves, this is pretty much why we use sunscreen to prevent from getting sun cancer when you're exposed to the sunlight for too long. All right, and then on the lower end, you have your radio waves. So this is how we listen to the radio when we're in our cars. All right, this is on the lower frequency end of the spectrum. All right, and the sunlight, the waves from the sun, this is under the visible light scale, and it ranges from violet down to red. All right, so this is just a picture of the different types of waves. So our ground waves, this is our radio waves, as well as our TV rays. We also have satellite. These are more long, long distance waves. And then we have our cell phones. Those are long distance waves as well. So ham radios, military radios, police radios, those are all short waves as well. All right, so we also have the microwaves. These waves are dangerous too if you're exposed to them over short distances, over long amounts of time. You also have infrared. This is pretty much showing the temperature of the image that you're taking a photo of. All right, and this is the spectrum of light through the visible light waves. So it ranges from red, orange, yellow, green, blue, and violet. And then again, the UV rays can be dangerous if you're exposed to them for a prolonged period of time. They can cause skin cancer. So your X-rays, this is what we use to look past the flesh of the skin into the bone density areas. So anytime someone, breaks or fractures their ankle or breaks a leg or something like that, these x-rays pretty much show the bone structure of that human uh, or animal's anatomy. All right, so gamma rays, these are rays that take place out in deep space. They are high frequency waves. We also have galaxy visible light waves here. Also on the gamma rays, so these higher frequency waves, we are usually protected from those higher frequency waves because of Earth's natural shield, magnetic shield, which protects us from things like solar flares and things of that nature. All right, so with the magnetic waves, we have the travel due to a speed that's at relatively the speed of light. So the speed of the waves is equal to the wavelength times the frequency, which we talked about in a recent chapter. I think that was chapter 5 when we talked about waves, except we used V for the speed instead of C, which is the speed of light comparison. Also in chapter 7, it talks about optics. So these are your mirrors and your lenses. All right, so you have reflections through mirrors. So you have a regular reflection, which is a mirror of what you see from that object that's being reflected. And then you have diffuse reflection. So that's when you have a glare of light versus a complete image that's mirroring itself. And then there's different types of mirrors. Okay, so we have spherical mirrors. They can be concave and they can be convex. So concave, this is when your focal point or your focal length is positive. And then convex mirrors are when your focal length is negative. So your concave mirrors, these are your small makeup mirrors that people use to put on makeup. We also have concave mirrors that cook food through solar cookers. There are also convex mirrors. So these are the mirrors that are on your car for your rear views, your side mirrors. And then convex mirrors, you might see them in parking garages, upward so that you could see people, that are in their cars kind of coming around the curb. Those are convex mirrors. All right, you also have refraction of light. So this is the change in speed of light as it moves from one medium to another. And a medium just means the stuff that it's moving through. So water is a medium, air is a medium, vacuum is a medium, same thing as air. All right, so the bending of light depends on the reflection of the stuff that it's moving through. All right, so here, skip past. All right, so here you have different glasses of water with objects. On the left-hand side, you have a straw and a glass. If you look upward, you can see the straw moving into the blue colored water. So they probably just use food coloring here. And then if you look through the water, right, the bottom of the straw looks different than when you look through the air to the bottom of the straw, right? So you kind of get like a double edge right here. So on the right hand side, you have glasses of water with a bottle in the back. And as you can see, the refraction of the light due to the bottle is kind of different for the one on the left versus the one on the right. All right. All right. So the index of refraction, this is a equation where the speed of light in the vacuum is divided by the speed of light in the medium. Right, so that equation is n, the index of refraction is denoted by lowercase n, and it's equal to our speed of light, which is c, divided by the speed of light in the medium, which is b. So these are some common indexes of refraction. So the vacuum of the medium of a vacuum and air are the same. They are at an index of 1. Water is slightly higher. Ice is slightly less than the refraction of water, all right, because ice is less dense. All right, we talked about density earlier in the semester. All right, and these are the differences between glass and a diamond. All right. Moving on. So if you ever went to the eye doctor, you have seen this image before. This pretty much determines whether you have good vision or bad vision. So the way we see things and how light is reflected and reflected in our eyes also determines our vision as well. All right, so dispersion is the separation of white light into colors due to the different refractive indices for the different wavelengths. All right, so here you have a this is a clear triangle pyramid, and you have white light beaming in. And as it beams in, this glass kind of reflects the white light into separate colors. So from violet to green to red, that is your uh, visible light spectrum. So anytime you have dispersion by refraction, you get the separation of white light into multiple colors. So anytime you see a rainbow, this is when you have sunlight that is reflecting and refracting off of water droplets, so vapor in the air. All right, so you have your sunlight and it beams into the water droplets. All right, and it does a turn, so it's reflected first and then it's refracted back to you, and that's what you're seeing when the white light from the sun turns into multiple colors due to that reflection and refraction. All right. So diffraction and interference. So light it can act as a wave, all right, and when it diffracts, it's bending as it travels through some sort of opening or interference, and it can combine with other light waves. All right, so there's different slit experiments that have been done by physicists over time that explains that when you have light waves and it is beamed through a small opening within some sort of wall or outlet, all right, the waves are going to travel through that slit and it beams outward in a sort of wave-like pattern. So it has wavelets as it goes through the openings in the wall. All right, so a more famous experiment is Young's experiment. This is a double slit experiment where sunlight is taken through multiple slits through the walls just to study the wave-like pattern of the light that comes through those slits. All right, and they can overlap. The more slits there are, the more those waves will overlap each other. All right, so here are just some double slit, single slit patterns, as well as a diffraction pattern. All right, so polarization, this is when you have evidence of transverse wave nature in light. So the electric fields, which we did talk about electric fields last chapter, these are the fields that surround the charges. All of these are vibrating in the same direction. All right, so your polarizers, these are used to achieve polarized light. And polarization can occur from reflections off of shiny surfaces. All right, this right here is a picture of the human eye. So what I'm not going to do is make you memorize all of these parts. It's just here for your information. So up front, you have your pupil, you have your cornea. This is the thin layer covering your iris. You have your retina in the back that is connected to your optic nerve and your optic disc in the back. So again, I'm not going to make you memorize those parts. All right, so there are different types of eye, I don't want to call them diseases, but disabilities. You have nearsightedness and farsightedness. So nearsightedness, also called myopia, this is a common vision condition where you can see objects near you more clearly, but objects that are further away from you seem to be more blurry. All right. So this is when the shape of your eye causes the light rays to bend and refract incorrectly. All right. So farsightedness, this is the opposite. All right. So this is called hyperopia. So this is when you have, you can see objects more clearly that are near to you than further away. All right. And this is just how you see it, farsighted versus nearsightedness. All right. The differences between the two and the optic nerve. Not going to make you memorize that either. Color blindness is also another light reflecting and refracting condition. All right, so this is when you are not able to distinguish certain colors. And so this is like a color blindness test right here. So some of you may be able to see it, some of you may not. This is a red 9 within a green circle. Here is a green 17 within a red and orange circle. Down here you have 50 in red, and there's a mixture of darker green and lighter green colors. The circles are the same for the bottom row. So you have 18 in red here and then 34 in red on the last circle. All right, so chapter 7 is pretty much covering light, how it affects reflections, refractions through different mediums, such as water versus air versus a diamond or some clear structure that separates white light into colors. So that's the gist of chapter 7.